Welcome to the deep dive.
Yeah.
Okay, let's think about our five senses: sight, sound, touch, taste, and smell. Which one do you reckon is the most, underestimated, but also the one that maybe influences almost everything, our memories, even how we judge people?
Oh, it's definitely smell, without a doubt. Or olfaction, as we call it technically. It's all about perceiving these tiny chemical molecules floating around.
Right, olfaction.
And it's this really critical, often hidden force. It shapes our experience, maybe even civilization itself, way more than we consciously realize.
That's exactly what we're diving into today. We want to journey into this really intricate world of smell.
Yeah.
We'll look at the biology, its ancient roots, why it's so tangled up with our emotions, how it shapes societies, and even how AI is now kind of revolutionizing how we understand it.
And look, this isn't just about, ooh, that smells nice, or ooh, that's bad. It's like uncovering this hidden superpower you have.
A superpower. Okay, I like the sound of that.
Seriously. You might be genuinely amazed to hear that humans can actually tell the difference between, get this, at least 1 trillion different smells.
1 trillion. Wait, hang on. 1 trillion?
Absolutely.
What? That's astronomical. More precise than distinguishing colors or musical tones.
Quantitatively, yes, it surpasses them. And a lot of this is happening below our conscious radar.
So it's like this silent guardian working away in the background.
Exactly. A silent guardian, hugely powerful, but we often just, ignore it.
Okay, so where do we start? How on earth do we even sense all those trillions of odors? What's the mechanism?
Right. Well, the journey of a smell is pretty amazing. It starts when these tiny volatile molecules, the odorants, get inhaled. They travel up into your nasal cavity, way up high, to this special patch of tissue. It's called the olfactory epithelium.
Epithelium, got it.
And packed in there are millions of these specialized nerve cells, olfactory sensory neurons, or OSNs. They have these little hair-like bits poking out into the mucus layer.
Okay, so the molecules land there. Then what happens?
Yeah.
How does that become a signal the brain gets?
Well, when an odor molecule bumps into the right receptor on those little hairs, think of it like a key fitting into a lock, it sets off a whole cascade of events inside the neuron.
A cascade?
Yeah, like a tiny domino effect. G proteins activate, other molecules get made, ion channels open up, and boom! You get an electrical signal. That chemical message just got turned into neural code.
Wow. Okay, so we have an electrical signal. Where does it go next? Up into the brain somewhere.
Exactly. These signals travel along the olfactory nerves. They actually pass through this thin, bony plate with tiny holes in it, the cribriform plate, directly into the olfactory bulb at the front of the brain.
Okay, the olfactory bulb.
And here's something really neat. All the neurons that have the same type of receptor, meaning they detect the same kind of molecule shape, all send their signals to the same specific little processing unit in the bulb called a glomerulus.
So it's highly organized.
Very organized. At this convergence, it really boosts sensitivity and helps us tell smells apart.
Now, this is where I remember reading something quite unique about smell compared to our other senses.
Ah, yes. The thalamus bypass.
Exactly. All our other senses, sight, sound, touch, taste, they all have to stop off at this central relay station in the brain, the thalamus, before going to their main processing areas.
Right. It's like a grand central station for sensory info.
But not smell. Olfaction just skips it.
It totally skips it. The signals go directly from the olfactory bulb to what we call the primary olfactory cortex, but also straight into key parts of the limbic system.
The limbic system, that's the emotional brain, right?
That's right. Areas like the amygdala, which is crucial for emotion, and the hippocampus, vital for memory formation, and also the orbitofrontal cortex, involved in decision-making.
So that's why a smell can just instantly trigger a feeling or a really vivid memory, like that famous Proust's Madeleine moment everyone talks about.
Precisely. It's a direct hotline to your emotions and memories, bypassing conscious, rational thought processes initially. It hits you right in the feels, so to speak.
Okay, but hang on. You said 1 trillion smells, but earlier you mentioned we only have about 400 types of these olfactory receptors. How does that maths work? 400 receptors, 1 trillion smells.
The paradox. Excellent question. It doesn't seem to add up, does it?
Not really.
The answer lies in something called combinatorial coding.
Combinatorial coding. Okay.
Think of it like letters forming words or musical notes forming chords. A single smell molecule doesn't usually activate just one receptor type. Instead, it activates a combination of several different receptor types, creating a unique pattern or signature. Your brain learns to interpret that specific pattern of activation as, say, rose or coffee or wet dog.
So it's not one receptor is one smell, it's the pattern across multiple receptors that defines the smell.
Exactly. It's the combination, the chord. And this complex, nonlinear way of processing is actually a huge challenge, but also a key insight for AI trying to understand or replicate human smell. It's not just about identifying single chemicals.
It's about reading the whole chemical symphony. It's much smarter than I give my nose credit for. Is there still debate about the very basic mechanism, like how the molecule actually triggers the receptor?
There is, though. One theory is much more dominant. The main one is the shape theory, basically the lock and key model we talked about. The molecule's shape fits the receptor.
Makes sense.
Then there's the vibration theory, which got a boost from Luca Turin. He proposed it's the molecule's quantum vibrations that matter. It predicted some interesting things, like with isotopes smelling different, but most scent researchers still lean heavily towards shape theory as the primary mechanism. The evidence is stronger there.
Okay. And on top of all this complexity, we don't all smell things the same way, do we? I know my partner and I argue about whether something smells good or bad all the time.
You absolutely don't. There's huge individual variation. Our genes for olfactory receptors are incredibly diverse. There are lots of tiny differences, polymorphisms.
Like what? Give me an example.
Okay, a classic one is androstenone. It's a steroid found in boar sweat and also human sweat to some extent.
Okay.
Appealing.
Huh. Well, depending on your version of one specific receptor gene, OR7D4, you might find it smells sweet, almost floral, or intensely unpleasant, like stale urine. Or you might not smell it at all.
Wow, so we're literally living in different smell worlds.
In subtle ways, yes. And you can imagine, if you find someone's natural scent subtly unpleasant, even if you don't consciously register why, it could create this little bit of subconscious friction or discomfort in social situations.
Yeah, I could explain a few things, maybe. Okay, so we've got the mechanics. Let's zoom out. Why is smell so fundamental? Why is it our silent guardian?
Well, olfaction is ancient, like really ancient, one of the oldest senses. For early humans, and still for us now, it was absolutely fundamental for survival.
Also, think about it. Finding food, ripe fruit, prey animals, detecting danger predators lurking, spoiled food that could kill you, smoke from a fire, a gas leak in modern times, even identifying potential mates. It's all about gathering critical intel from the chemical world around us.
Makes sense. It's environmental intelligence.
Exactly. And there's even that fascinating cooking hypothesis.
Oh yeah, tell me about that again. That one kind of blew my mind.
It suggests that the sheer pleasure we get from smelling and then tasting cooked food, especially meat, might have been a major driver in human evolution.
How?
Well, that sensory reward could have motivated early humans to figure out how to control fire, develop tools for cooking, which in turn made food more nutritious, easier to digest, safer. It could have literally fueled our brain development.
So enjoying the smell of a barbecue is evolutionary.
You could argue that. It connects us to something very deep in our past.
And it wasn't just about food, maybe. Did smell play a role in our social evolution too, like building communities?
There's evidence pointing that way. It's interesting that the parts of the Homo sapiens brain linked to smell and higher level cognition are significantly larger compared to, say, Neanderthals.
Really?
Yeah. One idea is that a more sophisticated sense of smell might have helped us recognize kin, maybe differentiate between us and them, fostering group cohesion, building those complex social networks that are our hallmark.
It still strikes me as bizarre, though, this incredible power, 1 trillion odors.
Yeah.
And yet, consciously, we rank smell so low. Why the disconnect?
It really is a paradox. I think it comes back to that unique brain wiring we discussed.
The direct link to emotion and memory.
Exactly, because it often bypasses that conscious analytical processing. Initially, its influence feels more subconscious, automatic. We feel the effect of a smell, comfort, danger, nostalgia, often before we consciously label the smell itself, so its power operates beneath the surface.
And when that sense is gone, when someone loses their sense of smell, the impact is huge, isn't it? It's not just about missing the taste of food.
Oh, absolutely devastating. Anosmia, the complete loss of smell, or even hyposmia, a reduced sense, is strongly linked to depression, anxiety, feelings of isolation, being disconnected from the world.
Wow.
It really underscores how fundamental smell is to our psychological well-being, our sense of safety, our connection to others, and the environment. things we totally take for granted until they're gone. Optimizing our olfactory world isn't trivial. It's about psychological health.
Okay, let's dig deeper into that connection mind-heart smell. We mentioned Proust, but how deep does this memory link go? For me, it's like the smell of old books takes me straight back to my grandparents' house.
Oh yeah, everyone has those. That direct neural pathway makes smell arguably the most powerful memory trigger. And odor can just unlock these incredibly vivid, detailed, emotionally charged recollections seemingly out of nowhere.
It's almost like time travel.
It really is. And of course, industries like perfumery and even food marketing, they know this. They're literally trying to bottle nostalgia or comfort or desire.
And it's not just specific memories, right? Ambient smells, the general scent of a place, could just change your mood subtly.
Definitely. Subconsciously. Studies clearly show pleasant background scents. Think lavender. Citrus can promote calmness, reduce anxiety. Unpleasant odors, they do the opposite. Increase stress, trigger negative moods.
So our social interactions are probably way more smelly than we think.
Oh, for sure. Your nose is constantly gathering subconscious cues about people and places, influencing things like trust, rapport, maybe even first impressions, long before your conscious brain catches up.
So how far does that influence go? Does it affect our actual decisions? Who we're attracted to?
Well, natural body odor, for example, although we try hard to mask it, carries a surprising amount of information. Potential cues about health, maybe genetic compatibility, even emotional state.
Genetic compatibility, like the MHC gene stuff.
Exactly, the major histocompatibility complex. The idea, still debated but intriguing, is that we might be subtly drawn to partners with different MHC genes, which could give offspring a more robust immune system. And maybe we detect that through smell.
Kissing is a way to get a good sniff.
That's one theory, a very intimate smell and taste assessment. More broadly, research shows people are more helpful, more pro-social in pleasantly scented environments. And smell definitely influences perceptions of attractiveness. It can even cause rapid physiological changes, blood pressure shifts, pupils dilating.
Just from a smell. Incredible. Okay, and let's talk health again. You mentioned the loss of smell is serious, but can changes in our sense of smell actually tell us something about our health?
Hugely important point.
Yes.
Beyond the immediate impacts of smell loss isolation, safety risks, like not smelling gas or smoke, a declining sense of smell is now recognized as a significant early warning sign.
Early sign of what?
Several major neurodegenerative diseases, Parkinson's, Alzheimer's, Huntington's disease. Often, olfactory problems show up sometimes a decade or more before the more classic motor or cognitive symptoms become obvious.
Years before, wow. So it's like a canary in the coal mine for brain health.
That's a great analogy. It really is. Olfactory function is also known to be altered in patients with depression, sometimes even when they're in remission.
So tracking someone's sense of smell could be a non-invasive way to monitor brain health.
Potentially, yes. It highlights that olfactory health isn't just a side issue. It's potentially a really valuable proxy for overall brain health, emotional regulation, even how socially engaged someone is. Monitoring it could be a powerful tool, especially for early detection.
This takes us nicely into this societal side of things.
Huh?
How has smell shaped cultures, history, even power structures?
Oh, profoundly. Throughout history, smells have been loaded with meaning: ritualistic, economic, symbolic. Think ancient Egypt. Priests burning incense like frankincense and myrrh wasn't just air freshener. It was seen as a way to communicate with the gods, purify spaces.
So smell was part of their spiritual technology.
You could say that. And in Hindu temples, sandalwood, camphor symbols of purity. Roman funerals used perfumes and incense, partly to manage the odors of death, but also tied to ideas of purification and transition. And historically, cities just smelled different. Pervasive sense of waste, decay, industry.
A very different smellscape than today.
Completely. And smell became deeply tied to social status and class.
How so?
Well, historian Alain Corbin wrote about 18th century France how evolving ideas about hygiene meant pleasant personal scents became associated with the aristocracy, with wealth, moral uprightness. Conversely, stench was linked to poverty, disease, moral degradation.
I remember reading George Orwell said something blunt about that.
He did. He controversially suggested the real secret of class distinctions in the West was basically that the lower classes smell. It's harsh, but it shows how powerfully smell was used to draw social lines.
And this links to old medical ideas too, right? Like the miasma theory.
Absolutely. The belief that diseases like cholera or the plague were spread by bad air, by foul smells or miasmas.
Which wasn't true scientifically.
No, germ theory eventually replaced it. But miasma theory, despite being wrong, had a huge impact on public health in the 19th century. It drove massive sanitation projects, building sewers, improving ventilation, cleaning up cities, all in an effort to eliminate bad smells and the diseases they supposedly carried. Fear of stench led to cleaner cities.
Okay, now for a darker, more critical point. How has smell been, well, weaponized, used to justify prejudice?
This is crucial and uncomfortable. History shows multiple instances where specific smells were, frankly, invented or deliberately attributed to marginalized groups. It was a tool for dehumanization.
Can you give examples?
Well, there are historical accounts describing enslaved people in horrific, unhygienic conditions, and then using the resulting odors to frame them as inherently foul or lesser. Similarly, racist yellow peril narratives in the late 19th and early 20th centuries often explicitly linked Chinatowns with foul odors to justify discrimination and segregation.
So, inventing a smell stereotype to reinforce power.
Precisely. It shows how societal rules about what smells right or wrong aren't neutral. They're deeply tangled up with power, prejudice, and constructing who belongs and who doesn't. This is sometimes called olfactory racism.
Wow. So smells aren't just perceived, they're interpreted through these social lenses. How does this play out more subtly day to day?
Well, the field of olfactics studies exactly that, how smell influences behavior. We know scents trigger memories, affect mood. Shared preferences for certain smells can help bond groups.
Like fans of the same perfume.
Maybe. Or shared food smells. Conversely, finding an odor unpleasant can create social distance. It's this constant, subtle negotiation happening through our noses.
And what's considered pleasant or unpleasant varies wildly, doesn't it, culturally?
Oh, massively. Think about certain fermented foods. The smell of durian fruit, or strong cheese, or fermented fish sauce, deeply loved in some cultures, considered revolting in others. And research has even found a correlation. People who score high on body odor disgust sensitivity, basically, how easily disgusted they are by body odors, also tend to show stronger prejudice towards outgroups they perceive as having different hygiene norms.
So our gut reaction to a smell can actually correlate with social biases. That's sobering.
It shows how deep these connections run. But on a more positive note, we're also learning how to recover historical smell.
Recover them. How?
Projects like Odiropa are using AI, believe it or not. They're doing sensory mining of historical texts and images in digital archives to identify references to smells.
And then what?
And then working with chemists and perfumers, they try to recreate those historical smellscapes. Imagine smelling the actual air of a 17th century Amsterdam canal or a Victorian library. It offers this incredibly visceral connection to the past.
That's amazing. A completely new way to experience history. Okay, let's connect some threads. How does smell act as a sort of blueprint for social order or even influence our moral compass?
Well, think about societal rules. Most cultures have strong norms against foul odors in public spaces, right?
Sure. Politeness dictates you don't subject others to bad smells.
Exactly. And these rules are heavily backed up by ideas about health and cleanliness. Pleasant smells get equated with virtue, safety, goodness, something advertising plays on constantly. Because smell is inherently public, it pervades shared space. It becomes a site of social regulation.
And you mentioned disgust earlier. That primal feeling, often triggered by smell.
Yes, that powerful disgust reaction, which likely evolved to help us avoid disease, rotten food, waste, etc., seems to bleed over into our moral judgments.
How so?
Studies have shown that inducing feelings of disgust, sometimes using unpleasant smells, can actually make people judge moral transgressions more harshly, even if the smell is totally unrelated to the situation.
Seriously, a bad smell makes you a tougher judge.
It seems so sometimes. It suggests that these ancient biological rules about avoiding foulness form a kind of foundation. They get built upon, moralized, connecting physical cleanliness with moral purity and stench with degradation. It's a bridge from biology to social norms.
And there's this final, really interesting feedback loop you mentioned between smell, our social lives, and our brains.
Yes, this crucial interdependence. It seems to work both ways.
How?
Well, research suggests that having a rich, complex social life, lots of interaction, is actually associated with better olfactory function. Social engagement might even protect against smell decline as we age.
So being social keeps your nose sharp.
It seems to contribute. But the flip side is also true. Losing your sense of smell can lead to social withdrawal, isolation, depression.
Which, as you said, can impact cognitive health.
Exactly. Which might even worsen olfactory decline. It's this interconnected web: social health, cognitive health, olfactory health, all influence each other. It argues for a holistic view, where fostering social connection and healthy sensory environments are both important protective factors.
Okay, this growing understanding and our ability to create and deploy scents brings us to some tricky ethical areas. Scentscaping in public places, is that becoming common?
It is, increasingly. Think about hotels with signature scents, retail stores using specific aromas to make you feel relaxed, or maybe even spend more, supermarkets pumping out the smell of baking bread.
Right, to make you linger and buy more.
Potentially. And this deliberate manipulation raises big ethical questions. Given how powerfully and subconsciously smell affects us, do we have a right to know when the air is being scented? Do we have a right to opt out? This idea of olfactory autonomy.
And we have those historical warnings ringing in our ears.
Exactly. That history of olfactory racism, of using smell to categorize and control people, is a stark reminder that scent can be weaponized. It can be used to create social division, not just pleasant experiences. We need to be mindful of that potential as these technologies develop.
What about the whole human pheromones debate? Is that still a thing? Are companies still trying to sell us attraction sprays?
Oh, the debate rages on, and the commercial interest is definitely still there. Scientifically, it's highly controversial.
Lie.
Well, while pheromones are clearly vital for communication in many animals, the evidence for specific behavior-triggering pheromones in humans is weak. Studies claiming effects from substances like androstenedione often face criticism about methodology, real-world relevance.
We don't have the same equipment, right? That VNO thing.
Exactly. Humans don't appear to have a functional vomeronasal organ, the structure animals use to detect many pheromones. Our scent signature is incredibly complex. Genetics, diet, microbiome, environment all play a role. Trying to boil attraction down to one or two molecules is probably far too simplistic.
So maybe hold off on buying that love potion.
Probably wise. Now, a related but different ethical area is emerging around our environmental smells.
What do you mean?
This idea of olfactory environmental ethics. It suggests we should value natural smellscapes, the scent of a forest after rain, the salty air at the coast. These are part of our environmental heritage, sensory anchors.
And pollution ruins them.
Right. But it also raises questions about olfactory rights more broadly. Do we have a right to air that's free from pervasive, unwanted artificial scents? Or even excessive natural odors caused by, say, industrial farming? It's about the quality of our shared atmospheric environment.
That's a really interesting concept. Okay, let's shift gears to the future, which seems to be arriving fast. AI, the nose of the future. How is AI even smelling things?
Well, it starts with digitizing the set. You use lab instruments, typically gas chromatography, mass spectrometry, GCMS.
Okay, fancy lab gear.
Right. It basically separates out all the individual chemical components of a smell and identifies them. It gives you a chemical fingerprint.
Like breaking down a perfume into its ingredients list.
Exactly. And that complex data, that list of molecules and their amounts, gets turned into a digital format, a scent encoding that AI algorithms can then learn from and analyze.
And what can AI do with that digital smell, especially in healthcare?
This is one of the most exciting areas. AI-powered sensors, often called e-noses, can analyze the volatile organic compounds, VOCs, in your breath.
The chemicals we breathe out.
Yes. And it turns out that various diseases, lung cancer, diabetes, Parkinson's, even infections, produce unique VOC signatures in the breath. AI is getting incredibly good at detecting these patterns, sometimes years before traditional symptoms appear.
Years. That's revolutionary for early diagnosis.
It truly could be. Non-invasive, quick, potentially very accurate. We're also seeing potential for continuous monitoring, maybe analyzing sweat for glucose levels or stress markers.
Wow. Okay, beyond health. What about, say, food or the environment?
Huge applications there, too. Quality control in the food industry. E-nose is detecting spoilage or contamination much faster and maybe more reliably than humans.
No more sniffing the milk carton, uncertainly.
Maybe not. In agriculture, monitoring soil health, detecting plant diseases before they spread. Environmental monitoring, sniffing out pollutants in the air or water in real time. It's about giving us superhuman chemical sensing abilities.
And it's changing creative fields, too, like making perfumes.
Definitely. Traditional perfumery involves a lot of intuition, trial, and error. AI can accelerate this dramatically.
Yeah.
Algorithmic perfumery platforms can analyze vast databases of ingredients and formulas, predict how combinations will smell, suggest novel pairings, even tailor scents to individual preferences based on data. It can cut development time from years down to days or weeks.
So AI as a perfumer's assistant, or maybe even collaborator.
Exactly, a very powerful one. And then there's the really futuristic stuff, bringing smell to virtual reality.
Ah, yes, the smell-o-vision dream. Is that actually happening?
It's getting closer. Forget those clunky old attempts. Modern digital scent technology aims to deliver precise, timed puffs of scent synchronized with VR or AR experiences.
So you could actually smell the coffee in a virtual cafe, or the gunpowder in a game.
That's the goal. Imagine Therapeutic uses calming lavender scents during VR therapy for PTSD. Educational uses smelling historical environments, or just truly immersive entertainment. Adding smell is that next frontier for sensory realism.
The potential seems almost science fiction.
Right.
What else is on the horizon?
Oh, it's vast. Handheld tricorder-like devices with the smelling power of a dog's nose detecting trace chemicals, allergens, maybe early signs of illness. Using AI olfaction to spot patterns indicative of a potential pandemic outbreak before it spreads widely.
Wow.
Integrating smell data with other AI senses, vision, audio for richer understanding, smart homes adjusting air quality based on detected compounds. Retailers predicting buying behavior based on ambient scent responses. AI might never feel smell like we do, but its analytical power is immense.
Okay, so bringing this all home, we have this deep understanding of smell's power, and now AI is supercharging our ability to analyze and manipulate it. How do we use this for good? To build a healthier, more educated, better society?
Right, let's synthesize. For a healthy society, the potential of AI diagnostics for early disease detection is huge. We also need to think about designing healthier smellscapes in our cities, reducing odor pollution, preserving natural scents, and recognizing that social connection and good olfactory experiences protect overall health.
And for a more educated society, it sounds like smell needs to be on the curriculum.
Absolutely. We need greater public awareness of how much smell influences us subconsciously. Imagine teaching olfactory history, maybe using those AI recreated scents, explaining the combinatorial code. It fosters scientific literacy and maybe even empathy, understanding we all live in slightly different sensory worlds.
And for a good society, this is where ethics really comes in, especially with AI.
Critically, we need to consciously design AI systems and scent technologies to avoid replicating or amplifying those historical biases, like olfactory racism. Developing clear ethical guidelines for scentscaping, focusing on transparency, consent, those olfactory rights we talked about. Maybe even consciously designing environments to use scent subtly to promote calm or cooperation.
But who stands to gain most from all this? And could anyone lose out?
The potential benefits for public health and quality of life are widespread, but we need to be careful. People with chemical sensitivities could suffer if scentscaping isn't managed well. Marginalized groups could be harmed if AI profiling based on scent is misused. And access to these technologies, especially in healthcare, needs to be equitable, not just for the wealthy. These are vital considerations.
So responsible innovation is key. What does that look like in practice?
It means developing those ethical frameworks up front, explicitly including olfactory rights. Promoting olfactory literacy is vital, ensuring fair access to the benefits, valuing and protecting natural smellscapes, and crucially, fostering collaboration. Scientists, AI developers, ethicists, urban planners, policymakers all need to be part of the conversation.
This deep dive has really hammered home that smell isn't just a minor sense. It's this ancient, incredibly sophisticated, profoundly influential architect of our reality, woven into our biology, emotions, memories, social fabric, even our moral judgments.
It really is.
Yeah.
And AI offers this incredible lens to understand it better and powerful tools to interact with it. But that power demands responsibility. We need robust ethical thinking to ensure these advances genuinely contribute to a healthier, more informed, and fairer world, not new forms of control or division.
So as you go about your day after listening to this, maybe pay a little more attention. Consider this. How many of your choices, your feelings, your memories today might be subtly guided by the sense around you, often without you even noticing?
And what could we all gain individually and as a society if we became just a little more aware, a little more olfactorily intelligent?
This is DigitView.